We are Group 7. In this video, we will present our analytical video report for the KMK 2563 Human Algorithm Challenge. The objective of this challenge was to apply computational thinking to design, execute, and evaluate a human-based algorithm in a real environment. In this report, we will explain our process following the computational thinking stages, like decomposition, pattern recognition, abstraction, algorithm design, live execution, and evaluation.
We begin our process with decomposition by breaking the challenge environment into smaller and more manageable components. Instead of viewing the area as one larger space, we divided it into nodes such as the starting point, checkpoint, turning point, and the final destination. We also identified possible paths connecting these nodes. This composition helped us understand the structure of the environment and reduce complexity during road planning.
I'll explain to you pattern identification generalization. For 3.1, pattern identification. Through a repeat practice, we observed several recurring movement patterns. These patterns were identified by comparing multiple trial runs and discussing observation as a group. The most patterns identified were repeated hesitation at complex junction, faster movement on straight path, delay when communication was unclear. Pattern generalization. The identified patterns were generalized into movement principles that could be applied in any similar environment. For example, we generalized that simplifying instruction at junction reduce hesitation regardless of location. This generalization supported more consistent and predictable algorithm behavior. Is abstraction and modeling. For abstraction of the environment to manage complexity, we apply abstraction by selecting only relevant information for decision making. Factors such as distance and estimate time were prioritized, while unnecessary environmental detail were ignored. This allowed us to focus on efficiency rather than visual complexity. Graph modeling. The abstract environment was modeled as a weight graph. In this model, we use node represent checkpoints, each represent movement path, weight represent estimated time or distance.
Algorithm design and constraint. Based on abstraction model, we designed two main algorithms. For the first one is the pathfinder algorithm and the strategist algorithm. The pathfinder is responsible to route selection and movement instruction, while the strategist monitors constraints such as delay, obstacles, and miscommunication. For example, if the chosen path is blocked, the pathfinder switches to the next lowest cost path. If delay occurs, the strategist intervenes and adjusts the strategy. We also anticipated possible error and include mitigation strategy to handle unexpected situations. Live education. This section shows our live execution of the Human Algorithm Challenge. During the live run, each team member performed their assigned to role consistently. The pathfinder issue, movement instruction, the strategy monitors, constraint and support member assisted education and documentation. The video evidence demonstrates how the algorithm was applied in real time.
The strategist team was not fully successful in blocking the pathfinder from getting the ball. However, our positioning and movement were effective in limiting the pathfinder's movement, making it more difficult for them to reach the ball easily. By blocking certain routes, like we go to left and right, we were able to slow them down and reduce their available option. Despite this, the pathfinder was still able to find where to reach the ball. To improve, the strategist team should focus on blocking directly at the ball, like turn around rather than only along the path. By controlling the area where the ball is located, we can better prevent the pathfinder from taking the position and strengthen our overall strategy. For our reflection, the strategist team was not successful in completely blocking the pathfinder from getting the ball. However, we were able to limit their movement by blocking certain paths and slowing them down. This made it harder for them to reach the ball. From this activity, we learned that blocking paths alone is not enough. To improve, we should block closer to the ball so the pathfinder can attack it easily. This will help us use better positioning and improve our strategies in algorithm.
So, in conclusion, this project demonstrates how computational thinking can be applied to solve real-world problems. Through decomposition, pattern recognition, abstract and algorithm design, we successfully executed the human algorithm challenge. Thank you for watching.